CLO is students will be able to solve in writing for x using quadratics, standard form, the quadratic formula, and the following language. If-then statements, quadratic, isolates, standard form, quadratic formula, and distributes. So what do you think you're going to learn in this lesson? So this whole time we've been solving for x with quadratics. And remember, if it's a quadratic, it's always going to have how many answers? We always have two answers when we solve for quadratics. And this time we're going to do it from standard form. And to do it from standard form, we use something called the quadratic formula. So remember, all standard form is a specific way to write a quadratic that looks like, and then in standard form, it always looks like this, where it's ax squared plus the bx plus the c. And this is in the most proper form. So the quadratic formula is how we solve for x when we are in standard form. So that's all it is. It's just a formula that some guy created. And he said, if it's in standard form to solve for x, this formula always works. There's a long proof that proves why it will always work, and we don't need to get into that right now. Just know that this is the formula, and this is what you use when you're in standard form to solve for x. So how does it work? Well, you're just going to start by taking the formula. We're going to step one is to plug the letters into that formula. The problem with that is we have to figure out what the letters are. So if this is my equation, it's not in proper form, because proper form would put the ax squared first, and this is not the ax squared, it's the x term. So if it's not in proper form, the easiest thing to do is to just pull out what a, b, and c are. For example, a is always the number that's right in front of the x squared. So right now, what's the number in front of the x squared? Well, we have a negative, and then if there's no number there, it's an invisible 1. B is always the number in front of x. So right now, what's the number in front of x? 6. And C is always the number alone. And right now, what's the number that's alone? It's a negative 10 because of the minus in front. So now all we really do is we plug those letters into this formula. So negative, I'm going to put parentheses around all my letters because it's going to help. So negative b. Right now, b is 6. So I'm going to put 6 into that. And I'm also going to come over here and put 6 into this b. One says a, and a right now is negative 1. So I'm going to put negative 1 right there. And then the c right now is going to be negative 10. And the last a is also negative 1 because a is negative 1. So I've done step 1 where I plug the letters into the formula. Step 2 says to simplify under the radical and the denominator. Well, simplify just means turn into one number. Radical means square root. So I take this, they want everything under the square root to become one number. Well, if I go into Desmos, 6 squared is 36. I can take this and replace it with 36. Next is a negative 4, parentheses negative 1, parentheses negative 10. So all negative 4 times negative 1 times negative 10 becomes negative 40. So after the 36, I'm going to write minus 40 because my answer was a negative 40. Well, I'm still not done simplifying under my radical because I still have to do 36 minus 40. And if I do 36 minus 40, I get negative 4. So when I simplify under the radical, I get negative 4. But I also have to do and the denominator. Denominator just means bottom of the fraction. And on the bottom of the fraction, 2 times negative 1 is negative 2. So now that I've done that step, I've simplified under the radical and the denominator. I'm going to take my answer and do step 3. Just to actually take the square root. Or you're going to just simplify it if the answer calls for radical form. So if the question at the beginning said leave your answer in radical form right here, then you would just simplify it. But it doesn't say that. So we're just going to take the square root. So if I come in here into Desmos, I try to take the square root with -4, it tells me it's undefined. Why is it undefined? There's no answer in the calculator because it's a -4, and nothing times itself is a negative. Well, not in the real world. So if we remember, first you do the square root of +4, which is 2. So this -4 can split into -1 times 4. But the 4, when you take the square root, becomes 2. So I'm going to take the 4 out from there. But there's still the negative under the square root. And a -1 under the square root means what? That the answer is going to be imaginary and that it's an I. So that once I took this and simplified it in my square root, the square root of -4 becomes plus and negative the 2i. So now step 4 is to take your answer and to split it into 2 answers. There's the one with the plus, and there's the one with the minus. 2 i's. Those are my 2 answers. However, step 5 says to simplify my answers. So simplify means turn into one number, if you can. On the top, can I add -6 with the 2 i's or subtract it with the 2 i's? No, I cannot, because I can't combine my real number with my imaginary number. Therefore, I cannot simplify the 2 top ones together. Remember, fraction line means divide. Can I divide both my top numbers by -2? Actually, technically, I can. So if I do -6 divided by -2, I get out a +3. And then when I do +2 onto the top, divided by the -2 down here, I end up with a -1i. But I don't have to write the 1, so it's just a -i. And if I do it over here, again, a negative divided by a negative will become a +3, because 6 divided by 2 is 3. But then I have to do it with this guy, and -2 divided by -2 this time becomes a +1i. So technically, these would be your 2 answers for x. X equals 3 minus I and 3 plus I for this one. So that's how you would solve it for x if we are in standard form already. But what if we don't start in standard form? This is the easiest one, because if you start out in factored form, to go to standard, you just distribute. If we're in vertex form, to go to standard, we also just distribute. If you don't start in standard form, it's the easiest one to get to. And we've done it a lot already in the last few lessons. So for this first example, the instructions first say to convert into standard form. So if it's not in standard form, what form is it currently in? It's in factored form, and to get to standard form, I just have to distribute, which just means to multiply it out. So I'm going to take my first term, my 3x, and multiply it to the x, and multiply it to the -5. So 3x times x is 3x squared. 3x times the -5 is -15x's. Then I take my second term, my -1, and I multiply it to both the x and the -5 as well. -1 times x is -1x. -1 times -5 becomes +5. So to finish converting it into standard form, I have to combine my like terms. These are my only 3x squareds. These two can combine though. Minus 15x minus 1x becomes negative 16x. And then my plus 5 is the only just number. So now we are in standard form. However, we must still solve for x. And since we're in standard form, how are we going to solve for x? Well, we're going to use the quadratic formula. So I'm going to go ahead and come up here and grab the blank quadratic formula. All right, so to use the quadratic formula, I first have to pull out my a, b, and c. What is a? It's 3. What is b? Negative 16. And then what's c? 5. So first I take my formula and I replace all the letters with what they are. So the b right now is a negative 16. This first negative is a part of the formula. So in the parentheses, I still have to write negative 16 for that b. And in this parentheses, I have a negative 16 as well. A right now is 3, C is 5, and on the bottom, the A is 3. This minus 4 and this 2 is always there, just like this negative. It's a part of the formula. The only thing you replace are the letters. So then, step 2 is to simplify things. So negative means what in math? A negative means it's a positive, so I don't need the 2 negatives. Negative 16 squared, if I do a negative times a negative, it's going to be positive. 16 times 16 is 256. So this part becomes 256. Then, if I do negative 4 times the 3 times the 5, I get negative 60. So then this, after the 256, I'm going to run and write minus because it was negative, and then the numbers became 60. And on the bottom, 2 times 3 is 6. I'm not quite done simplifying though, because under the square root, I can do 256 minus the 60, and I end up with 196. My next step is actually take the square root of 196 or simplify it down. But if I scroll up, the instructions just say use the quadratic formula to solve for x. So since they don't say leave it in radical form, I'm going to just put it in the calculator. So if I take the square root of this, I find out it's 14. It's a whole number. It's not even a decimal. I can get rid of this and find out that it's 14. So now I'm going to take my answers and split it into 2. So one with just the plus, and then one with just the minus. To finish up my answers, I have to simplify them. So if I do 16 plus 14, 16 plus 14, I get 30 on top of this one. This one, if I do 16 minus 14, I get 2. So I'm still not done because I can divide. If I do 30 divided by that 6, I get out the answer 5. And if I do 2 divided by 6, I get out the answer of 0.333333. 0.3333. Because it's a decimal, you could have just left this as 2 over 6, and I would have counted it as a good answer, but not this one, because since I could divide, you should divide. Because I divided and got a whole number right here. But since this one was a decimal, I will take decimal or fraction as an answer. So this is what x equals for this problem. The one all the way up here. So this one is starting in which form? This one's in vertex form, and I want to convert it to standard form, but I just do that by distributing. This one, I just have to be super careful to follow all the rules correctly. So the 3's in front still. And then x minus 5 squared means there's 2 parentheses being multiplied together. Then we add 6. So quickly, I'm only going to think about the 2 parentheses. So the 3 is going to still be there. I'm going to multiply the 2 parentheses together, and then at the end, the plus 6 is still going to be there. But right now, I just have to focus on parenthesis times parenthesis. So to do that, first, it's going to be this x times this x, which is going to be an x squared. Then x times negative 5 is negative 5 x's. I have to do this negative 5 times this x to get another negative 5 x's. Finally, negative 5 times the negative 5 at the end becomes positive 25. But I can't forget to combine my like terms. And negative 5x with another negative 5x becomes negative 10 x's. And then I still have my plus 6 at the end. So this 3 in front in the beginning of this expression, this parentheses being squared, means that I need to do 3 times all of this. So now that I know what all of this is, I still have to times the 3 in front to all of them. So 3 times x squared is just 3x squared. 3 times negative 10 is negative 30x. And 3 times 25 is 75. And I still have that plus 6 at the end that was not in my parentheses, that was not getting times to the 3. So basically, I took this one and I distributed it into everyone in the parentheses. And then finally, I have to combine like terms one more time. So this is only 3x squareds. These are the only x's, and it's negative 30. But I have plus 75 plus 6. And 75 plus 6 is going to be 81. So now we are in standard form. Are we done? No, because if we run back up to the instructions, it says to convert it to standard form, but then also to use the quadratic formula to solve for x. And then this time we're going to leave our answer in radical form. So let's go ahead and do the quadratic formula. Remember, the first thing we want to do is list our a, b, and c. So what's our a in this equation? 3. What's our b? Negative 30. And what's our c? Positive 81. So let's take them and plug them into the quadratic formula. So negative b is negative 30. So it's the double negative again. Negative 30 goes in that parentheses too. This a is going to be the 3. C is going to be 81. And on the bottom, the a is the 3. So I've done step 1 where I plug it into the formula. Step 2 is to start simplifying. Again, negative becomes positive 30. Negative 30 squared is positive 900. I have negative 4 times 3 times 81. Negative 4 times 3 times 81. It's negative 972. Negative 972. And on the bottom, 2 times 3 becomes 6. I'm almost done, except I still need to subtract. So I still have 30 plus minus square roots, and then 900 minus 972 ends up being negative 72 under that square root. And at this point, I would try to put this into the calculator if I was doing it the normal way, but because it's negative, I would end up with i's. But that doesn't really matter because at the beginning, the instruction says to leave it in radical form, which means instead of putting it into a calculator, I'm going to start breaking it apart. So negative 72 will divide into negative 1 times 72. 72 can then divide by 2 and become 36. When I divide 36 by 2, I get 18. When I divide 18 by 2, I get 9. Take 9 away and divide it by 2, I get a decimal, so it doesn't work. But if I divide it by 3, then I get out 3. I'm almost done, except what should negative 1 split into? Negative 1 turns into I times I. So now if it's under there twice, like these two i's, I can delete them from under and put them out front. These two 2's, I can delete them from under and put them out front once. This 2 stuck, but these two 3's, I can delete them from under and put them out once. So then when I re-simplify things, in front, 2 times 3 times I, 2 times 3 becomes 6. And then we have the I. And now that there's nothing left with the 2, I can delete them away. Parentheses away. So now I've simplified my radical. So I have to split it into 2 answers, one with just the plus and one with just the minus. My last step would be to combine them together if I could. In my numerators, I can't combine the 30 and this because A, they're imaginary, and B, they're radicals. They're square roots, and the 30 is not. So they can't combine. However, can I divide both 30 and 6 by 6? Well, if I do 30 divided by 6, I get a whole number. If I got a decimal, then I would have to stop, and these would be my 2 answers. But since when I divided 30 by 6, I got a whole number out. I got 5. And then when I divide 6 by 6, I get out 1. So now there is no more dividing by 6. The answer is just 5 plus 1i root 2. And I don't even need the 1i. It could just be I. Same thing over here, because both of them can be divided by 6. 30 divided by 6 will be the 5. 6 divided by 6 is going to be a negative 1 this time. So that the answer ends up being the same. It's just with the minus 1i square root 2. So now these are 2 answers for what x equals for this one. So the important part to note here is the reason why we got rid of the dividing by 6 is only because both divided by 6, both the 30 and the 6. If it was anything else, for example, let's pretend it was 30 plus 5i root 2 over 6. Well, 30 can divide by 6, sure, but then when I do 5 divided by 6, I get a decimal. And it's not good to write a decimal here. Like if I wrote the 5 here and then wrote 0.88888333, whatever that decimal was, that's not proper. It's more proper to leave it like this than it is to divide, unless both of them evenly divide. All right, so jumping back to our CLO. The vocabulary words were if-then statements. For example, you might say, if it's in standard form, then I use what to isolate x. So remember, you're trying to use these words to make it work. So to use quadratic, I might say, if it is in a quadratic, then to isolate x, I have to see what form it is in. And if it is in standard form, then so on and so forth. And explain everything you learned from this lesson, trying your best to use these words.